Okay, method of components. Fantastic, we're here. You're like, but didn't we already do this? You're gonna look at this and it's gonna look very familiar. And we sort of did. It's just last time we were talking about things, we had like, a perfectly vertical and then a perfectly horizontal force. And we said, okay, what is the resultant? Let's add one together. And that worked. These are always triangles. We're just looking at triangles. And what you didn't realize was that when we were talking about distances and the lengths of different sides of triangles, well, that's all just as helpful when we come into forces. So in the method of components, what we do is we take each individual force vector and we draw it as a triangle. So I have this force 1, okay? And I figure out what the x component and the y component is because it's going to be a right triangle. So this will be f1y, this will be f1x. Okay, and then do the same thing for f2. I know what the initial angle is, most likely. And so I once again break it into a triangle. I find that this is f2. Well, I can figure out f2x, and this is f2y. Glorious. And then my resultant vector, this one right here that is the addition of the two, is simply me adding together my y components to get its y component, and adding together its x components to get its x component. And the great thing is this works for however many vectors you have. Just be very careful about direction, because if one of them is going negative, you got to make sure that you put your signs right. So let's look at these steps in a little bit more detail. Okay, so we're going to algebraically sum the exponents for each force in the x direction. So we're going to sum the forces in the x direction. Like I said, we break it into our components. We add those together to get our resultant vector in the x direction. We do the exact same thing for the y. We find our y components, and then we add those together to get our y component. If we want to find the magnitude, we can then just use Pythagorean theorem, because we'll have a new triangle. We'll have this big triangle where we know our y, and we'll know our x, and therefore we can just take the magnitude of it as r is equal to the square root of rx squared, that's me adding all the x components together, plus ry squared, that's me adding all the y components together, to get that magnitude. Boom. If I want to find the angle of inclination from the x-axis, I do that by using tan theta x is equal to ry over rx. I know what ry is, I know what rx is. If I'm looking at my triangle, that means I know opposite, I know adjacent, and I want this angle theta right here, which is to the positive x-axis. And so opposite over adjacent is tan of theta. So tan of theta equals opposite over adjacent, which is equal to ry over rx. So, and that will be enough to solve. You'll have all the information that you need. Now, let's go to the next one, because sometimes we have 3 or more component forces, and that's where things get really weird. In these kind of situations, I really strongly suggest you do not use the parallelogram method. Some people really like that, and in all honesty, before we had really amazing calculators, before we had great trig functions, this is the way you did it. Like, you could just do it visually. You could draw things. And like I could just say, okay, well, this arrow is going to go that direction. Okay, cool. This arrow is going down. Okay. And this arrow goes down like that. Okay. And so I start here, and I end here. And that's my resultant vector. Right there. That's R. And I'm done. Like, that's all I have to do. As long as all my angles and distances are perfect, I have gotten the correct answer. So, I mean, if you're a whiz with a ruler and some graph paper, go ahead. Or you can use graphing software like SolidWorks or things to finish these problems very quickly. But remember, you need to learn how to do this by hand as well. Okay, so don't try to take every single shortcut. You need to learn how to do these things by hand. So when we have 3 or more concurrent forces, well, the method of components is just the way it's at, because it's just the same method every single time. You break it into components, you add all the components together, and you solve. So the only really difference from solving for 2 concurrent forces is that you keep finding x and y components. Like, you'll have 3 or 4 components. I got 4 vectors. I'll have 4 x components. and I'll have 4 y components, and then I will add those together to get my rx and ry. So, this right here is example 3.3 from your textbook, and let's go ahead and try to solve this really quickly, okay? Let's try to solve this real quickly. So, how am I going to do it? Well, let's see, I've got 8 kips, and that's cosine of, we're going to break that apart. So we got 8 kips right here, that's 8, okay. Turn into a triangle, that's 25 degrees. So that will be 8 sine of 25 because it's opposite over hypotenuse. And this will be 8 cosine of 25 because that's adjacent over hypotenuse. And I do it again right here for that one, being very careful to draw the correct directions. And what I get is that this is 12, this is 30, and so 12 opposite over hypotenuse, that would be sine of 30 would be just 6. I'll go ahead and put that in there because I know it. And then 12 adjacent over hypotenuse would be cosine of 30. Okay. Be very careful though because this would be negative 6. And I keep on going and I say, okay, I've got this one over here and that's going to be 10 kips long. That's an angle of 60 degrees. So that's 60. And so 10 sine of 60, okay, right here, 10 sine of 60. 10 cosine of 60 will just be 5. And I have one more right here, a 50-degree angle. Once again, I gotta make sure that this is both negative and this one is negative because they're going in the opposite direction. And then I've got this 50-degree angle, that's 5 kips. Make my components, 50 degrees. And this will be adjacent over hypotenuse, so 5 cosine of 50, and this would be opposite over hypotenuse, so 5 sine of 50, and this one will be negative because it's going to the left. And then if I want to find my resultant forces, well, I just say Rx is going to be the components in that direction, Ry in that, so let's add them all together. And what I'll get is 12 cosine of 30 plus 8 cosine of 25 minus 5 cosine of 30 will equal the Rx component. Ry would be equal to 8 sine of 25, let's see, plus 5 sine of 50, minus 6 minus 10 sine of 60. And that'll be my Ry component. I'm not going to bother to do the math here because I'm already going a little bit over my time. But you can see how you could solve this. It's the same thing every single time. I just have 1, 2, 3, 4 triangles, and then I was done. After that, it's all just addition and subtraction. So be very careful with these problems, and they can be very, very simple. Just do your best to follow the steps all the way through. So, thanks for listening, and I'll see you all next time. Bye-bye.